Alrighty, welcome back, and now for something completely different. And as you can see, I have two kits from PM Research. I have the metal lathe and the milling machine. And you might be wondering why I'm starting new projects when I'm neck deep in three other pretty big projects, like the Nimitz I'm building for my friend, the 1/8 scale Jaguar, and the 1/4 scale speeder bike. And the answer to that is, well, because that's what I do. Also, I'm not saying I'm starting these. This video is an introduction to these and why I have them and what the plan is. And maybe I'll get a jump start on this one. But a jump start isn't really a start. At least that's what I'm saying. Plus, I kind of need a break from those other projects. That's the way I am. Once I work on something for several weeks, I kind of get tired of it. I need to take a break from it. So after this video, it's back to the Nimitz. And I need to then focus on that Nimitz until it's done. Because, again, that's for a friend of mine. So I need to get that done. And then once the Nimitz is done, then I can get back to focusing on the Jaguar and the speeder bike. And these projects are going to kind of be my in-between. Like when I get bored and need a break, then maybe I'll knock out a few of these parts. But let's talk about these. Again, these are from a company called PM Research. And I first found out about these several years ago. I was watching, I'll be honest, there's countless machinists on YouTube, and I can't watch everybody because I don't have that kind of time. So I have to pick and choose who I watch. And so I watch Blondie Hacks and Joe Pye. And I would say that, Joe Pye, he is a professional machinist. He works in a professional machine shop, and he is very good at what he does. And I enjoy watching his videos. I learn a lot from him, but I will probably never be at his level. He's been a professional machinist for over 20 years, maybe 25 years or I don't know, but that's what he does. And again, I'm okay with acknowledging the fact that I will never be at that level. But I still watch his videos because I can still learn a lot from them. Now, Blondie Hacks, she's still way better than me, but she claims to be a hobbyist machinist, and she has more hobby machine tools. So having said that, I kind of prefer watching Blondie Hacks because she's more along my line of machining. Now, again, she's way better than me. I'll never be up to her level, but I can relate to her better, if that makes any sense, just because of machining styles and concepts. But again, I highly recommend you guys check out Blondie Hacks and Joe Pye. They both can teach you a lot. Or at least they're both teaching me a lot. And right now, Blondie Hacks is working on a live steam locomotive, which is incredibly cool. So one of my favorite builds on YouTube at this point. That's even including my own. But I look forward to her videos every week. Now, Blondie Hacks has built some PM Research models. PM Research has, obviously machine tools like lathes, milling machines, scrapers, drill presses, stuff like that. But they also have live steam engines, steam models, and Blondie Hacks has done some of their live steam engines. Joe Pye, several years ago, did the lathe, and more recently completed the milling machine. But in between those, he did the shaper, and he's also done the drill press and the arbor press and the bench grinder. But I don't remember which one I saw that introduced me to the PM Research models first. I don't remember if it was Blondie Hacks doing a steam engine or Joe Pye doing the lathe. I don't remember what it was. But when I first saw one of them do a PM Research kit, I went to the PM Research website and I saw all of their different kits, and I wanted this one. I wanted the milling machine one because I really like milling machines. I like running them, even though I'm not that great at them. There's just something about milling machines that I'm drawn to. And you may remember that I did a milling machine model not too long ago. I did this one several months ago. Unfortunately, this one is plastic, And even though it does move, you know, you can turn the cranks and the bed moves and raises and lowers, and I think it's very cool, despite what my friend Sean thinks. I'm just kidding, Sean. But this is just plastic, and it's, even though it does kind of move, it's not really functional. If you tried to really crank things, it would probably break, and this is very fragile. This is all cast aluminum. And one other thing, these are kind of the same scale. I'll compare sizes here in a little bit, but they're kind of the same scale. So anyways, when I saw this, I really wanted this. But at the time, and again, I'm going back probably, I don't know, 2 or 3 years, give or take. At the time, this was $140 and the lathe was $120. And at that time, I only had a lathe. I did not have an actual milling machine. And I did not know if I had the ability to make this without a milling machine. So about a year ago, maybe two, a couple of years ago, I don't remember, I went to Cabin Fever Model Engineering Expo in York, Pennsylvania, and PM Research had a table set up showing all of their products. And I actually met the guy who designed this stuff. And I asked him if it would be possible to build the milling machine with only a lathe. And he asked if I had a mill adapter for the lathe. And I said, yes, but it's a janky homemade one that I made myself. That kind of works. And I did a video on this a while ago, a couple of years ago. I did a video on how I made this. This attaches to my lathe, and then I can attach parts here, and then this gives me a Z-axis for the lathe. So this is a milling attachment, and it works. It's not the best thing in the world I've ever made, but it kind of works. So I said I had this, and then he said, "Are you an experienced machinist?" And I said, "No, I'm a novice at best." And then he kind of paused and him and hawed a bit, and he said, "Well," he goes, "that would be a challenge for even an experienced machinist." So I said, "Okay, thank you. I won't waste my $140. And kind of left it at that. Now, shortly after then, I got my desktop milling machine, and I installed a DRO. And I've been practicing with that a lot, you know, getting better at hitting dimensions. And then just recently, a couple of weeks ago, these came up on eBay. And I got the lathe for $60, and I got the milling machine for $70. And if you go to the website now, like I said several years ago, the milling machine was $140 and this was $120, if I remember right. I could be off, but I think that's what I remember. Now this one is closer to $160, I think. $160 or $180. It's gone up a bit. And this is about $140 to $150. Again, it's been a while since I've looked. I could be way off. But the prices have gone up. So again, I got this one for $60. I got this one for $70. And there is an issue with the shipping. I got lost in shipping and went back to the seller. They had to resend it back to me. And eBay offered me a $40 refund. So yeah, I got these for almost half of what this would cost new. So at those prices, I couldn't afford to not buy them. And I knew when I got them that I wouldn't have time yet to start on them. That's why I'm not starting on them right now. So let's open these up and see what's in here, and we'll talk about what I've already done to kind of prepare working on them. Now let's take a look in the milling machine first, because when I actually do start on these, I'm going to do the lathe first, because I'm assuming the lathe will be a little bit easier. So I'm thinking I should probably start that one first. So let's take a look at this one, and then we'll look at the lathe. In the milling machine kit, we get the blueprints, and here are the kit pieces. I'll open up the drawings here in just a little bit. We get a bunch of castings. This is the main body casting. Now again, I did watch Joe Pye's build on this, learned a lot of good techniques. Now I will say though, that I really want to try to figure things out myself. I really want to do this from my own, what's the word I'm looking for? From my own abilities. I don't want to just copy the way Joe Pye did it, even though the way he did it is good. I don't want to just copy that. I want to try to use my own brain and figure out how to do things for myself. Having said that, I will probably do some of the things Joe Pye did, and if I do, I will definitely give Joe Pye credit. I don't want to claim any credit for something someone else did. Now, it's possible that I do something unintentionally similar to the way Joe Pye did it, and if I don't give him credit, then that just means I didn't realize that Joe Pye did it. Again, it's been a while since I've seen his videos on this. I don't remember exactly what he did for every single part. If I get stuck somewhere, I'll go back and rewatch his video on that part and see how he did it, and then I'll give him credit for helping me out. Now, one thing, for example, what he did on his, he milled out the opening for the door, made a whole new door and hinges with a little handle so you can open and close here and see the inside of it. Because this is just a solid casting. So he made an opening door here. Now, honestly, I kind of wish I would not have seen that, because I think I would have thought to do that on my own. But I don't know if I would have or not. I think I would have, because it's kind of an obvious thing to want to put in an actual functioning door here. I mean, I think that's kind of an obvious thing to do. I think I would have thought of that. So I'm probably going to do that as well. However, I'm not going to go back and rewatch Joe Pye's video on how he did it. I want to see if I can figure out how to do it myself. I do know that his hinges he made, although they were beautiful, they were a little over-engineered for me. No offense, Joe, if you're watching this. I'm sure you're not, but you never know. I'm going to try to come up with a simpler hinge design, but I don't know. We'll see how it goes. I might not even do that at all. We'll see. But just to kind of show you that this is the same scale as the plastic model I built. Here's the plastic model I built. Here's the PM Rsearch casted one. They're pretty much the same size. The only thing, this is a vertical mill. Well, it could be a horizontal because there's a shaft this way. This is just a horizontal mill. I don't have any experience running a horizontal mill. All of my experience is on a vertical mill. So I really wish this was a vertical mill. To me, it would be a lot cooler if this was a vertical mill. But it's a horizontal mill, which is fine. It's still cool. But again, these are same scale. So it'll be kind of cool to have those displayed side by side when this one's done in a couple of years, maybe. I don't know. But anyways, there's the main body casting. And here's that part goes there. And then you've got this that goes here, somewhere there, something like that. I don't know. And this part goes somewhere. I don't know. I gotta, like I said, I gotta look at the the destructions. So anyways, you get all the castings. You get all the castings, and then you get bags of hardware. Not sure what's in here. The bag's kind of dirty, dusty. Some smaller castings. Some other hardware, looks like some belts. Little bag of nuts and bolts and screws and pins. And you get a bag of bar stock. It looks like one fell out. That bag is ripped. Hopefully I'm not missing anything, but it's just bar stock. Shouldn't be that big of a deal to replace anything in there. So that is what's in the box. Let's take a look at the drawings here. Okay, so here's the drawings that came with the kit. 3 pages. I think they're like 24 by 36, give or take. You have 3 pages. I mean, beautifully drawn. And so we have the exploded view. and of all the pieces with assembly notes, parts list, and then there's 2 more pages with measured drawings for all of the parts. So there's another page and the 3rd page. Now these are fairly old. I think I got one of the original kits. I mean, the instructions they look old, and I don't want to say yellowed, but the box is definitely kind of old and yellowed. And, but this is for the milling machine. And let's take a look at the lathe. I will more than likely not be starting the milling machine anytime soon. But let's take a look at the lathe. You notice the box is also fairly yellowed, and this is an older version because when you take a look in here, here's the folded drawings, but also inside here, we get the drawings for a 4-jaw chuck. Now, the kit does not include the material for the 4-jaw chuck. The newer kits now do. If you were to buy this kit now, I'm 99% sure it comes with the material to make the chuck. This one does not. They just give you the drawings for it. Here's our castings. We've got the main bed casting. We've got the legs. And carriage, cross slide, the apron, all of those individual castings. And then we have the bag of gear stock and bar stock and hardware and other stuff in here. So these are the pieces in the kit. Let's take a look at the drawings. So just like the milling machine, you get 3 pages. The first page is the exploded view. So we have the exploded view, and then again 2 more pages of all of the individual various pieces. Now let me show you what I've already done, because for one thing, for me, this is kind of awkward to work from. Like if I'm making this piece, I don't want to have this whole print opened up just so I can get the measurements and look at this piece. Plus, if I did that, I know I'm going to destroy these drawings. I'm going to get oil on it. I'm going to get cutting fluid on it. I'm going to get my fingerprints all over it. They're going to get torn. And I don't want to damage these prints. So what I did is I went to my local copy shop, and I had all of these, the lathe and the milling machine, I had all of these pages printed, and I got 2 of each print. Actually, I asked for 2 of each print, and they gave me 3 of each print. They only charged me for 2, so I'm not complaining. So here's what we got now. This is the lathe. There's a print for the lathe, and so we got the exploded view, and of course all of the pages. So I did this to preserve the original drawings, the original prints. And I asked for 2 of each so I could keep one whole, and the other one I could cut out each one to put in a book to make it easier to work from. But again, like I said, they made 3 of each page, which, like I said, I'm not going to complain about that, but I'm not sure why they did that. I mean, they only charged me for 2, like I said, and I kind of feel bad. I kind of feel like I should go back and pay the difference, but I don't know, it's kind of their mistake. But here's what's going on here. I'm not done with this yet, but I cut out each piece. For example, here's the legs, and this is probably what I'm going to get a jump start on. This is probably one of the easier things, because all I have to do is deck off the top and bottom and put in 4 holes. But But so this is probably what I'm going to do here in just a moment, and I'll show you the setup that I'm going to do for that. But the plan is to copy each one of these on a full-size sheet and 3-hole punch it and put it in the book. And now a lot of these are fairly small. For example, once I print this on a full-sized sheet like that, what I will do is, like, on the top, I'll write down the material. Like this is a casting, but some of these are cold rolled steel, some are brass, some are gear stock, whatever. So I'll write down the material, and I'll write down the tools list, like the drill bit size I need, the tap size I need, everything I need, plus the assembly notes, because each page has its own assembly notes. And for example, right here, so these are all the assembly notes. And so on each page, I'll have the assembly notes, so I don't have to keep referring back to this. So basically, each part will have its own print with everything on it that I need to then make that part. Because keep in mind, I'm not a professional machinist. I need all the help I can get. So this way I can just focus on one part at a time and just look at what I need and put my own notes down there. I'm going to study all the other pieces and parts that go to it. Put my own notes, because some of this stuff, some of the notes says fit at assembly, you know. Sometimes they don't give you every single dimension you might need. You have to calculate that yourself from the dimensions they do give you. So I'll do all of that on each page. Some parts might have 2 pages, maybe. I don't know. We'll just kind of see how that goes. Now, obviously, some of these parts are too big to fit on a single page, so they'll have to be folded, which isn't ideal, but, you know, like these 2 right here, those will just have to be folded. So again, not what I was hoping for, but, you know, it is what it is, I guess. Now, the expanded view or the exploded view, that obviously has to be folded up. So that'll get 3-hole punched and then folded up so I can see the assembly view. Keep in mind, I still have the originals and I still have the ones that are rolled up and untouched. So we've got that. This is your parts list. Now, something that I will also probably do, more than likely, there are a lot of gears and a lot of bushings. So one of these pages here has, right here, we have the gear table. So there's several gears, and there's gear stock that you just slice off what you want. But they just made a table here. Instead of having a print for each gear, they made this table. So for each gear, there's 11 gears. Some of them you need 2 of. They give you the tooth count and the pitch. And then they give you dimensions A, B, C, and D. Here, A, B, C, and D. Some have the hub, some don't. Some have a set screw, some don't. Again, this is going to be a lot for me to keep track of. So what I plan on doing is printing 11 pages. And each page will have its own gear drawn with the dimensions on it, so I can just focus on one gear at a time instead of going to here for each one that I do. It might be overkill, but again, for me, I feel like that's what I have to do to keep things straight. There's another table like this for the bushings and stuff. So again, that's the plan. So again, this book is not finished. I still need to make the copies and put all the notes. And there's still a lot of work to do here. But I think I should be able to get started on the legs. I think that'll give me a good pre-start. So let me get the legs out and let's take a look at those. All right, the castings themselves look pretty good. Just looking at the print, that has to be decked off. The feet have to be decked off. There's really no flash on these, which is nice. There's really not any file work I need to do on that, I don't think. A little bit of a sharp edge there. I might knock that off the file a little bit just to chamfer that a little bit, but really not needed. Basically, all I got to do is figure out how to hold these in the in my mill and deck the top and bottom off. These are the dimensions I'm looking for. Let's just kind of see what they are right now. Now, one thing, I'm used to using metric, and these are not metric, but I really like these calipers because I can put it to fractions. All right, so I can put these to fractions here. Let's just see what these measure now. Now this is the pour sprue, so I'm not going to measure across there. So I'm just going to measure from there to there, trying to keep that straight. And I'm at 2 and 25 1/28. So, and I need 2 and 3/16. Now, if we just convert that to metric, for example, if I go there, that's 55.76 millimeters. And 2 and 3/16. There's 2 and 3/16. And that's 55.55. So if we just kind of take a look, we are pretty much there. So, I mean, the casting is pretty much almost exactly where it needs to be. It's actually a little bit short. But here's the thing. Yeah, it's just a little bit short. Here's the thing, though. The height of this really is not critical, in my opinion. And this is a thing about the way, I machine things. As long as it looks good and it works, I'm okay with it. If I don't hit a dimension perfectly, I'm not going to stress out about it as long as I can still make it work. As long as things move without binding or being too loose or going to fall apart and it looks good, I don't stress out about exact dimensions. So anyways, what I'm going to do is I'm just going to deck that off until it's milled and I got a good surface. And the bottoms, I might not even touch. I might drag it across some sandpaper, maybe, just so they're not rough. But I don't even think I'm going to knock those feet off. And it looks like it just gets straight. But this is all they give you for the print. They don't show if these, once they're fully mounted, if they lean out at all. That top surface does look angled. The bottom feet don't, really. Yeah, they kind of do. Now, that could just be the draft. I'm sure that's just the draft angle. I kind of think it would look better if they were kicked out a tiny bit. But that's not what the print shows. They should just be straight up and down according to all they're giving me. They're not giving me a side view this way to show that angle. So I'm going to assume it's supposed to be flat, and I'm going to assume that the angles that are on there because of the draft for the casting, for the sand casting, so it could release from the mold. So I'm just going to mount these flat and straight. Let me see. Let me just make sure that they are flat. Looks a little better. They're pretty close. I think what I'm going to do is say that they're close enough to vertical off the bottoms of the feet. I mean, the castings were pretty good. And just a couple of swipes on some, what is that, 220? A couple of swipes on some 220 sandpaper, and they almost look machined. I mean, not really, but you know what I mean. So I'm going to say that they are flat to the bottom of the feet. So I'm going to trust that as my flat surface. And so I'm going to bank off of that and then deck the top off to get, I'm already below that dimension. So I'm just going to take the top off until that's flat to the feet. So let me get that set up and we'll show you what that looks like. Okay, so to hold the legs in place for machining, I have these brackets. This is left over from the DRO. This was a generic scale bracket for the DRO that I got for the milling machine. And I didn't use it. So what I'm going to do, I got a bolt, put that in the back, the washer, and this just happens to go on just like that. A washer and a nut. And so what I can do is just push that down so the feet are flat on the bottom of that. I'll get a wrench on that. That'll clamp that to there. Then I can put this in the vise, deck off that top, and that should be good. Now I know there's a lot of stick out, so I'm going to take really light cuts. And once I get that Z set, I can then take this off, put the other one in, and go to the same Z and make sure they're the same. So let me get this set up in the mill, and we'll see what that looks like. Okay, so I've got a 4-flute end mill. I think that's carbide. I'm not even sure. I think that came with some other stuff. I didn't buy it specifically for any particular job. Normally, I like to use a 2-flute for aluminum, but I'm going to take very light, minimal passes here, and I need to buy more end mills. That's something I need to do before I do too much more machining, because most of my end mills, like I said, I got them used with other stuff. This, I believe, is my sharpest one, and it does pretty well on aluminum, I think. So we'll try this. Again, I'm just going to deck it off until I get to that top surface. And I'm just going to look for all the Sharpie to go away is pretty much all. Most of that is sprue from the casting. And I got my DRO turned on, and once it's down where I want it, I'll set 0 for Z. And then I'll just unbolt this one, put the next one in, and then go to 0 and Z again, and then it should be good to go. So I need a new cooling fan. So there's still a little bit of black around here, but I think that's where the casting, the edge kind of starts to roll off. But it is, for the most part, flat. I mean, all the, I think that's pretty good. I think I'm happy with it right there. So I'm going to 0 the Z. And we'll take this one out, put the next one in, and we'll go to the same 0 on the Z. And then it should be ready for the holes to be drilled in it. The hold down seemed to work pretty well. Again, I was taking really light passes, really light cuts. So again, there's still some Sharpie, but again, that's just where it rolls over that edge there. The bulk of that is flat enough to bolt the lathe table to. So I think I'm happy with that. Looks pretty good. Let's get the other one in there. And again, I was taking really light cuts, so it took a while because I didn't want to take any chance of it catching too deep and kicking the part out. All right, this one has a little bit more of the Sharpie remaining. It has a little bit more of a dip off. So I'm going to take this down a little bit more, and then I'll put the other one in and bring it up to match. That's definitely better. I can live with that. So I'm going to swap it out. I actually went down about 0.2 millimeters, and so swap that out with the other one, and then we'll bring it to match. All right, that'll work. Next up, I'm going to drill the holes for the mounting holes to the bed. Okay, so on the print, they call for those mounting holes 45 drill. I don't have the exact right size, but I have one that's just a hair under. So I'll do that. And if it's too small when it comes to assembly, then by then I'll have the right drill. And I'll just open the hole up. But 1/4 inch back and 7/8 from here to here. So what I'm going to do is, first off, my DRO is on millimeters. So I've already changed those to millimeters, and I've drawn them on another piece of paper. But what I need to do first is find the center line and then move out 1/2 of 7/8 on each side. So I have an electric edge finder. So what I'm going to do is basically bring this, I'm going to find that surface first. And 0 the X, and just make sure it's the same on this side as well. Right there. So it's about 0.16 millimeters difference. I did not machine that surface, which maybe I should. It really doesn't matter. What I'll do is I'll put it a 1/4 inch back from this one, since this one is the shorter one. So I'll put it a 1/4 inch back from this one. So that'll just be a little bit longer, but again, it's not going to matter. So I'm going to have 0 on this one. So I'm going to 0 that. So now I need to find the center. So I'm going to come back on this side a 1/4 inch, which is, this is my new drawing right here. So 0.635 inches back, and then 11.113 on either side of center will give me the hole. So I'm going to find that edge at a 1/4 inch back, which is again 6.35. And this does kind of, you know what I need to do though? I need to first take it to 5 millimeters, right there, because that's a 10 millimeter ball. So I need to go to 5 millimeters and now zero the X. So now this is center line on that edge. So I'm going to come back in now to 6.35. And that kind of matters because those edges are kind of angled. So I want to pick up the point from the same point. I could do it anywhere theoretically to find the center, but I want to do it at the same point, which will be at the 6.35. So I'm just going to come in, and I did run some sandpaper over the edge to make sure there's no burr that'll hang me up. So I'll find the edge here. Zero the Y. And I'll come back to 6.35 here. And find the edge again. Now, all I did, I just rotated that around 180 because the ball might not be perfectly center. So by rotating at 180 from finding the edge here to finding the edge here, it'll get me a lot better. This is a cheap electric edge finder, so I don't trust, well, I know the ball's not perfectly centered, so by flipping at 180, that'll make it more better. So I'll find the edge here. And then I'll half the Y. And so now, if I take that to 0, that's center, and I'll bring this to 0. Actually, I want to bring this to the 1/4 inch, so 6.35. 6.35, and I'm going to 0 that. So now I'm at the 0, 0 point, which would be right there. So all I have to do now is go over 11.113, drill the hole, over here, drill the hole, and that's it. And then do the same thing for the other piece. Now, this drill bit is the closest one I have to the right size. I mean, it's just a hair under, but it's not sharp at all. So we'll see how this one goes. All right, I just have to do that again on the other one. That's what that looks like. Looks like the drawing. So the bolts will go up from the bottom and tap into the bed of the lathe. So I'm happy with that. Again, I just have to do that to the other one. I shouldn't have to readjust the X here because I'm going to leave that in place. I'll just have to re-find the center because obviously I'm not going to be able to get that perfect. I could have set up an end stop, which would have been a good idea, but I didn't think about that till right now. So I'll just have to find the center again and then drill those 2 holes on the other one. And then those will be done. So I think that this video is probably way too long, so I'm going to end it right here. You don't need to see me drill 2 more holes just like I did here. And I thank you for watching. I appreciate you for watching. And as always, until next time, thanks for watching.